Good afternoon, everybody. Thanks for attending today's Meet the Pro workshop series featuring Dr. Shannon Roberts from the University of Massachusetts. She's a mechanical engineer and industrial engineer. She's also the director of the Roberts Research Group, which is part of the Human Performances Lab. The focus of her research group is on novice drivers, feedback systems, and automated vehicles. Dr. Roberts earned her bachelor's in mechanical engineering from Massachusetts Institute of Technology and her master's and PhD in industrial engineering from the University of Wisconsin-Madison. Dr. Roberts has been a National Science Foundation Graduate Research Fellow, a Dwight D. Eisenhower Transportation Fellow at the U.S. Department of Transportation, and was voted by students as the Industrial Engineering Professor of the Year at UMass Amherst, as well as a Center for Research on Families Scholar at UMass. She's received the Stephanie Binder Young Professional Award from the Human Factors and Ergonomics Society. And I'm going to turn it over to you now, Shannon, to see if how you'd like to begin. Do you want me to start up the PowerPoint, or how would you like to go forward?
Yeah, you can start the PowerPoint. I'll go from there.
Okay, great. All right, Shannon, I'll turn it over to you.
Okay. So as Matt was saying, I'm Shannon Roberts, and I'm in the Mechanical and Industrial Engineering Department at UMass. Today, I'm going to talk about my background, how I got to where I am now, and I'm also going to talk about what I do as an industrial engineer and what my research is about, which is human factors. Can you go to the next slide?
Yep.
So actually, so right now I see like the editor view. Yes, yep. Perfect, yes.
Better?
Yes.
Okay.
Yes, perfect. So I'm originally from St. Louis, Missouri. A lot of people don't know where that is. It's in the middle of the country. It's known for the Gateway Arch, which is in the picture there. When I was 17, applying for colleges, being a typical Midwestern girl, I wanted to stay in the Midwest. My high school counselor, on a whim, she said, apply to this school in Massachusetts. I think you'll get in, and I think it'll be a really great opportunity for you. So I did apply, and magically I got in. Can you go to the next slide?
Sure.
And that school happened to be MIT, which is in Cambridge, Massachusetts. When I started at MIT, I wanted to be an astronaut. I thought it would be really cool to go to the moon and to build some sort of living situation on the moon. That's what I wanted my legacy to be. When I got to MIT, though, I got advice from a career counselor who said, being an astronaut is great. It's really fun. But if you do that, you won't be able to do anything else with your life in case it doesn't work out. So I decided to change my major to mechanical engineering. And that was a really good fit for me because mechanical engineering is all about doing things with your hands and making things and really getting down into the details and the weeds of like one of the core engineering majors. So I spent 4 years at MIT doing mechanical engineering. It was a really great experience. And I graduated in 2009. I know you guys are too young to realize what was going on 11 years ago, but it was a similar economic situation to what we're going through now, in the sense that it was a recession. So jobs were scarce, and I didn't want to take a job that I didn't really love. So I decided to go to graduate school. Next slide. I went to the University of Wisconsin-Madison, which most people don't know much about Wisconsin besides the fact that it has really great cheese, which it does. And it's also very, very cold, which it is. So I went to the University of Wisconsin-Madison, and I decided to change my major when I went to graduate school. When I was an undergrad at MIT, I was doing research in a lab focused on vehicles and vehicle safety. But the research I was doing wasn't related to mechanical engineering. It was actually related to industrial engineering. So when I went to graduate school, I changed my major to industrial engineering. Now, if you're paying attention by this point, you'll see that I'm on my third major. And I'm still here and I'm still doing fine. So if you decide to change what you want to do over time, that's totally fine. I went to University of Wisconsin-Madison. Originally, I was just planning on getting my master's degree, which takes about 2 years. But once I got there, I saw that maybe I wanted to stay in academia a bit longer and teach. So I decided to stay and get my PhD, which took 5 years. After I finished my PhD, next slide, I decided to go back to MIT. I really love Massachusetts. And even though I'm a Midwestern girl, I found that Massachusetts was just a better place to live. So when I finished, I decided to find a job in Massachusetts. One at MIT opened up at MIT Lincoln Laboratory, and I took it. I was working at Lincoln Laboratory, which is not in Cambridge, it's in Lexington, Massachusetts, for 2 years, doing work for the federal government. It was a really great time. I got to work on really cool projects that were related to national security. And after I was there for a while, I realized, I got my PhD so I could teach or so I could become a professor. I should probably go do that now. So I left MIT, and next slide, I came to the University of Massachusetts Amherst, where I became a professor in industrial engineering. So I've been at UMass Amherst for almost exactly 4 years now. It's been an amazing experience. Like I said before, I really love Massachusetts. So choosing UMass was great because I got to stay in this place that I really love. And I get to work with really great students who are super bright. You all will see this as you get older. You feel like your level of creativity declines. And so as I interact with students, I get all of my great ideas from them. So being at a university is great because I'm around young people who are really creative and thoughtful and engaging and really keep me inspired to do the work that I do. So next slide. Now I'm going to talk about industrial engineering because most people don't know what it is. When you think about the different engineering majors and you ask people what each one is about, when you ask them about industrial engineering, that's the answer. Well, that's the major that you get the worst responses for. So I want to tell you guys exactly what it is. So industrial engineering, or IE for short, is about the design, improvement, and installation of integrated systems. So industrial engineering is all about systems. It's not just one thing, you're looking at a combination of things. And those systems can be comprised of people, material, information, equipment, energy, a variety of different things. What's cool about industrial engineering, or what I think is really cool about industrial engineering, is that it's all about combining different fields together. And the fields that it combines are math, physics, and social sciences, along with like the typical engineering analysis and design. So what's really important for me and that combination of majors is to focus on math. My mother actually majored in math in college, which was kind of unheard of in her time because what do you do with the math major besides teach math? She found a job not doing math. But the important thing is she instilled in her children the importance of math and learning how to deal with numbers. So as an industrial engineer, I get to do math all the time. For me, that's exciting. I know for some people that can be kind of daunting. But if you love math, if you love physics, and the cool thing is the social science piece, right? That's not really associated with engineering, but with industrial engineering, it is. If you like any of those things and you also like engineering, industrial engineering is definitely the place that you want to be. Next slide. So in short, I know that definition was really long. You can think about industrial engineering as being about optimization. So how do you take this system of people, materials, information, and how do you optimize it to make sure it's the best that it can be? So when you think of industrial engineering, just think of optimization. If anyone ever asks you what it is, just say optimization and you'll be saying the right thing. Okay, next slide. Click one more time. There we go. So I told you guys what industrial engineering is, but it doesn't really tell you what industrial engineers do for a living. So next slide. Industrial engineers at a really high level, they just focus on making things better, right? They make systems better. The systems or the things that they can be focused on include products, like cars, computers, or phones. I know people who are industrial engineers who work on each one of those products. They can also make systems better, manufacturing systems, hospital systems, which is super important right now, financial systems. And they can also make life better. They can look at healthcare, housing, or education. And when I say better, that really depends on the field that you're working in. But generally speaking, better means you're making something that's higher quality, it's cheaper, it's easier, it's using less resources, so it's better for the planet, it's quicker, safer, faster, a variety of things. Better is, like I said, depending on the domain, but in general, you can think of it as those things. Oh, next slide. Good timing. So, industrial engineers make things better, and they're not just making things better for the sake of doing something cool. They want to make things better for people and for the world. What's really important about industrial engineering is that you have an effect on not just engineering, but society. So, I give an examples here of people at UMass who are industrial engineers and how they make life better. So the first one is what I do. I focus on optimizing cars and vehicle safety. And in particular, one of the things I work on is driver training. So making sure that you as a driver know what to do when you're on the road to make sure you're as safe as possible. There are other people at UMass who optimize patient flow in a hospital to make sure you get seen by a doctor quickly and as safely as possible. There are professors who optimize simulations and models, which are really great for predicting the next disease outbreak. This one particular professor, and you'll see her picture in a couple of slides, she's super busy right now with COVID-19 because all she does is focus on building computer models to know where the next outbreak is going to be. It's fascinating work and it's super important right now. And lastly, there's a professor at UMass who optimizes electricity grids to make sure that our electricity bills are as low as they possibly can be. Next slide. So like I was saying before, now I'm going to show you the people at UMass and the different things you can do in industrial engineering at UMass. So the first major within industrial engineering at UMass is engineering management. So this is related to all of the majors of engineering, and it's basically about when you work in engineering, you're in a team, and every team needs a manager. This field is specifically focused on managing a team of engineers. Next. The next one is systems engineering. So this is at a high level, how do you engineer systems? And these systems can be made up of a variety of things. But broadly speaking, they're usually looking at production systems or manufacturing systems. Next. We also have modeling and simulation, which I talked about a bit on the last slide. Next. There's operations research, which is one of the hallmarks of industrial engineering. And it is exactly what it says. It's about how do you operate things like manufacturing, hospitals, any large system. How does it operate? What are the logistics? How do you get the items from point A to point B? And last, we have human factors and ergonomics, which is my specialty. And I'm going to talk more about that in greater detail. So if you can go to the next. These are all of the professors at UMass, and I sort of placed them where their specializations are. So you can see we're all over the place. We have people who work in multiple areas, but in general, it's a really diverse group of people who are working on really cool and important problems. So next, I'm going to talk about human factors and ergonomics, which is my specialty. So the definition of human factors and ergonomics is it's a field that's concerned with how we apply what we know about people, including their limitations and their abilities, and how do we take that information to make sure we're designing technology, equipment, the environment that actually fits their abilities and limitations. So we want to design things that fit humans. Now, when you first think of that definition, you're saying, oh, well, aren't all things designed to fit humans? And you'd be surprised at things that aren't. And I'm going to show you examples of things that are not designed with human factors in mind. So next, you can think of human factors and ergonomics really simply as about making people happy with the stuff that they use. So I'm sure you guys have used technology in general that you really like, it's really efficient, it's safe, it does what it's supposed to do. And you can think of examples of technology that you use that you wish you wouldn't have to use, but you need to. So next slide. Here, I'm going to give you examples of things that were designed that don't consider human factors in ergonomics, and this will really drive home the point of what human factors is. So the first picture on the left is this wonderful thing called a butterfly ballot. So this particular butterfly ballot is from the election in 2000, which you guys probably weren't even alive then. But the point is, I think Matt knows this butterfly ballot.
Oh, yeah.
It was really bad. So I know it's small here, but if you were tasked with voting for the president using this ballot, you could potentially vote for the wrong person. And that's kind of sad. You don't want to go to the polling booth and be confused by the ballot and then vote for the wrong person. This was actually used in Florida. It's no longer used now. But as you can see, it doesn't really consider humans' abilities, right? You can't really tell where the arrows are pointing because they don't perfectly line up with all the dots. That's the problem. The second picture in the top at the middle is a lovely road sign that says right, but it's not pointing to the right. Now, signs like this actually exist on the roadways in the US. Now, if you were driving down the road and you saw this sign, I'm sure you would probably spend a few seconds trying to figure out exactly what was going on. Think about how far you can travel in a few seconds. Dangerous things can happen because you're trying to figure out what this road sign says. In the upper right is a door handle that has push on it. Now, usually when you see a door handle, you think pull. But in this case, they want you to push with the door handle. It's the opposite of what you expect. In the lower left-hand corner, this is a traffic signal that's not in the US, it was found in another country, but they're trying to control quite a few lanes of traffic, including bicyclists with one signal. And as you can see, some lights are red, meaning don't go, but some lights are green and some lights are yellow. Which one is for you? Who knows? And the last picture in the lower right is a wonderful Windows error message that I actually took a screenshot of from my computer. And it says something completed successfully, but it's an error message. Those two things are contradictory. You want whatever computer pop-up that you see to give you something consistently, whether it's a positive message or a negative message. Okay, now these examples are funny, but they are actually present in real life. And I'm sure you guys can imagine if you encountered these things, how frustrated you would be with actually using them. So the next slide, I'm going to show you guys examples of things that were designed with human factors in mind. So the first picture is that of a recycling container. And in particular, this container is used for newspaper. What makes this so good is the fact that the slot is sized so you can only put paper inside. That reinforces the fact that this receptacle is only for paper, not for cans, not for trash, not for food, not for anything else but paper. The next example is of a better door handle. Now, there's nothing for you to pull on this door handle. The only thing you could do is push to open it. There's no signs or words needed for you to know how to properly use this door, which is good. The next example is of an ergonomic mouse. Now, this is ergonomically shaped because if you were to lay your hand on top of the mouse, you would know exactly where your thumb, index, and middle finger were supposed to go. There's no confusion. The fourth example is of a pedestrian crosswalk sign. It's very obvious as to what you're supposed to do. You either get the stop hand symbol or you see the picture of a person successfully walking. And next to that, you see the timer, which is super important. It's very frustrating when you get to a pedestrian crosswalk and you see that you can go, but you don't know how much time you have. I've been in those situations where I don't know if I'm supposed to go or not, so I just wait until the next signal because I don't want to be in the middle of the road when cars can go, because that's when they start honking at you. And the last example is one of my favorites, and that's an iPhone. It's designed really, really well. I know people who work in the human factors division at Apple, and they spend years perfecting the phone to make sure it's intuitive and easy to use. Okay, next slide. All right, So I've given you kind of an in-depth look at human factors, but it doesn't really tell you what people do who have human factors degrees. So human factors and ergonomics engineers can work at a variety of places. Next slide. So keep going. They can work at all of these places shown on the slide. I literally know people who work at each one of these places who focus on human factors. So for example, I know human factors engineers at GM who focus on the design of the interface inside of the car to make sure that it's not distracting, yet it allows you to get from point A to point B safely. I know human factors engineers who work at Apple, like I was saying before, specifically those who work on the iPhone. I know human factors engineers who work at Caterpillar. So if you don't know Caterpillar, the company, they make heavy duty equipment that people use on farms and on big plots of land, essentially. They also make construction vehicles. So making sure that those vehicles, which can cause great harm because they can be quite big, making sure that the interfaces, the seat, the cab in general is designed in a way that the human can get their job done as efficiently and as safely as possible. Okay, next slide. So with that said, I want to talk about what I do at the Human Performance Laboratory at UMass. So the Human Performance Laboratory at UMass, or HPL for short, our research focuses, like I was saying before, on vehicle safety. And in particular, we look at 4 different things. Training systems, so how you train someone to be a good driver. We look a lot at automation. So with all the new technology that's put into cars, is it well designed and does it achieve its goal? We look at general principles of roadway design. So for those people who have been to Boston and you've seen the thing called the Big Dig, before that was actually dug up and put into place, that was simulated at the HPL at UMass to make sure it would achieve its goal. So people would know what the exit signs meant, what lane to be on, and so on. And lastly, we do a lot of work with vulnerable populations. So by vulnerable, we mean people who are more likely to be injured in a crash. So older drivers, younger drivers, pedestrians, and bicyclists. The way that we do this research is using a variety of different facilities. And the main thing is our driving simulator. So you can see a picture of that in the lower left-hand corner. It's essentially a really big video game. I love talking about it and I love showing it to teenagers because they get a kick out of driving a car really dangerously, but it's still safe at the same time because you're not going to crash. We also use virtual reality headsets. They're portable, they're great, they're really fast and quick, and they can teach you or train you very, very easily. We also use eye trackers. So we put an eye tracker on you and we see exactly what you look at to make sure that certain signage on the roadway, for example, is effective. And we also use physiological monitoring, which is really cool. So we can put you in a driving simulator and introduce you to a scenario, and we can measure your heart rate and your breathing rate and whether or not you sweat to see if it really essentially freaks you out. We want to make sure that we minimize those situations and we design roadways and interfaces that don't make you nervous. Okay, next slide. All right, so now I'm going to talk about some of the projects that I specifically do at UMass. So this part of the presentation is going to be interactive. I think the easiest way for us to do this is I'll ask you a question and then you guys can just say yes or no right afterwards. I think, Matt, you have to unmute them, or is that already set up?
Yeah, let's see. Go ahead and unmute yourselves, guys, and turn your mics on so we can hear you. Because this part, as you said, is going to require. There you go. All right. Okay. Andrew, do you know where that is, Andrew? If you click on the screen, you should see at the bottom a microphone button on your left, and it probably is red. So if you hit it, it should go clear. Okay, so Andrew, you can send me a chat as you weigh in. Okay.
Okay. So, first question. Raise your hand or just say yes or no if you have your driver's license or your permit.
Nope.
No.
Oh, 2 no's and 1 yes. Okay.
I was actually
All
supposed
right.
to start driving lessons like last month, but I can't because of COVID.
Of course.
Wow.
So unfortunate. Okay. So for the one person who said yes, let me know if you have had your driver's license or your temps for more than a few months. Yes. Good. Okay. And in general, I know this situation is kind of different and abnormal, but if you get a chance to drive more than once a week, let me know. Yes or no? Good. That's really
Not
good.
bad. Yeah.
Okay. So for the one person who drives, there are a lot of rules associated with having a driver's license. And even, I think it was, yes, Kieran, am I saying it right?
Yep.
Yes. I'm sure you also know these rules, even though you haven't started the process yet. But the rules include things like, you can't drive with teen passengers, you can't be out at certain times of the night. So for the one person who has their driver's license or their temps, let me know if you actually follow those rules. I won't tell anyone.
Andrew, do you follow those GDL rules? Broke them
Uh-oh,
once.
he broke them
Only
once.
once? Good for you.
That's pretty good. A lot of people break them more than once. Oh, it's to help a friend. Oh, okay. That's better than just doing it for fun. Okay. So I asked you these questions because, like I was saying before, a lot of our research has to do with younger drivers and in particular how you train them. So can you go to the next slide? So, oh, oopsie.
Let's see. Whoops. That was my fault. There we go.
There we go. So I'm going to talk about 3 projects that relate to younger drivers. The first one I did when I was a graduate student at University of Wisconsin. And I was trying to measure if having a friend who was a bad driver made you a bad driver. Now, when you first hear that, you say, of course not. My friends do whatever they want to do, and I do whatever I want to do, and it has no correlation. But my study actually proved that what your friends do has a really strong impact on what you do. And it's not just if you see the way your friends drive, because with your temps, of course, you can't drive with your friends anyway, but the way that they talk about driving, the way that you play a driving video game, all of these things have an influence on what you do as a driver unconsciously. So in general, try to hang out with people who are good drivers. It will make you a better driver. Another thing that I've been doing since I've gotten to UMass is a simulator study where we actually bring in friends and we put both of them in the car and we measure how likely you are to interact with your phone while driving when you're driving by yourself and when you're driving with your friend. And we also look at things like if you give your friend the phone to text or Snapchat or do something else while you're driving, or if you still try to do it yourself. So in addition to just asking questions about what your friends do, we're actually measuring what you do in the car with your friend and how that changes if you drive by yourself. In general, we see that you do the same thing whether you're driving with your friend or not, but it changes if your friend is a best friend or a casual acquaintance. So if you have a really close relationship with someone, you're more likely to do something different in the car than if you have someone sitting next to you who you're not as close with. Okay, next quiz. All right, so raise your hand or just let me know if you've ever taken a driver's education course. Yes? No? Okay. Raise your hand if your parent or your guardian or anyone else has tried to teach you how to drive. Yes?
No.
No? Okay. Now, opposite of that, raise your hand if someone else who wasn't your parent or guardian tried to teach you how to drive.
Nope. I
Nope.
I actually just entered high school, so
Oh, well, you'd be surprised at how many people have driven before they've gotten to high school, especially in Western Massachusetts. I know people who have driven, in particular if they live on a farm or have a large piece of land. I know people who have gotten behind the wheel at like 11 or 12 years old, just because it was a wide open space.
Wow.
Okay. So the last question, and you can answer this even if you don't know how to drive. Based on what you know right now, do you think there's more for you to know about how to drive?
Absolutely.
Yeah.
Good. You guys are continuous learners. That's a good way to be. Stay that way. Okay, next slide. So I asked these questions because they're all aimed at understanding how you were trained and how you learned how to drive. So can you go to slide 23?
Sure. Is this one 23? Nope.
Here we go. Perfect. So I'm going to talk about a few things that I worked on that focus on driver training. So the first picture on the far left, I did this study when I was working at an insurance company, Liberty Mutual, and we were trying to figure out if you tell someone how they drive, if that improves their estimation of how they drive. So what we find is that if you ask someone how they drive, most people say they're better than average. But statistically speaking, most people can't be better than average. There must be something wrong here, right? So we did this study to see if we can make people more calibrated to their actual driving performance. And for the most part, it worked. If you repeatedly tell people, no, that was good, no, you were wrong, yes, you were right, then over time, they do get better and they can better estimate their capabilities. In the middle is a study I did when I was at University of Wisconsin-Madison. And it was fun because we told people how they drove in comparison to their friends. So we ranked everyone and we basically gave people a grade. Now, being in high school, grades are usually very important. And so when you see your driving put into grade form and you're told that you're doing better or worse than your friends, it tends to be very effective in making you a better driver because you want to get the best grade. The last picture on the far right is a project that I worked on with people at the University of Iowa. And we were also giving people a grade as to how they drove. And in particular, we were looking at how they drove distracted. So we looked at whether they turned around and tried to get things in the back seat. We looked at if they used their cell phone, and we gave them a grade. And we told them how they did in comparison to everyone else. Once again, if you tell people that they're bad in comparison to other people, it really encourages them to change their behavior. Okay, last quiz. Okay, so everyone can answer this one. Say yes or no if you've heard of automated or self-driving cars.
Yeah.
Yes.
Good. Raise your hand, or rather say yes or no if you want to get one.
No.
No.
I don't think
Wow. Most people say yes to that question. Okay. Raise your hand, even if you guys say you don't want to get one. Raise your hand or say yes or no if you want to get one because you think it would allow you to do other things while driving.
No.
no.
Wow, you guys are really safe. All right, last question. Say yes or no if you think automated or self-driving vehicles will make our roads safer.
Eventually.
I think they can, but there's too many like coding the ethical choices and stuff into the programming is too difficult at this point.
Yeah, I mean,
Fair
right
enough.
now.
Good. You guys are very, very thoughtful. I wish we had undergraduates at UMass who were as thoughtful as you guys were. Okay, so now I'm going to talk about the work that I do that's related to automated or self-driving vehicles. Next slide. Okay, so one of the projects that I did a couple years ago was really looking at ride sharing services, so things like Uber and Lyft, and how we get people to be more comfortable with those services if they're automated. Most people know that, for example, Uber is testing their automated ride sharing services in places like Philadelphia and Arizona. So they're really going towards that model, right? Not having individual people driving the cars, but having the cars be automated. But we really wanted to know what were people's concerns about being in a car that's essentially a taxi without a driver. You'd be surprised at what they said, but they were really concerned about safety. So if you have multiple people in the backseat, they're all strangers, what happens when something bad happens and there's no driver to reconcile the situation? The second project I worked on which is shown in the middle there, is looking at, let me remember what I was doing with this one. Oh, yes. Looking at how people respond to if you're a pedestrian or a bicyclist and you see an automated vehicle on the roadway. So are you likely to understand what its actions are? Can you predict it, or do you need to be told what's happening? And the last picture on the right is an example of one of the interfaces inside of a Tesla. And in this project, I was really looking at how you design that interface to make sure that the driver knows what the car is doing. If you as a driver aren't comfortable with having this car essentially drive you around, then you're not going to use it. But at the same time, these systems tend to be safer, right? So if we have these systems in cars that are safer, but people don't feel comfortable using them, then there's no safety benefit. So how do we design a system to make sure that the driver knows what's happening, which in the end makes them more comfortable and makes them want to use the system? Okay, so I've described my research, I've described what human factors is, what industrial engineering is, and I talked about how I got to where I am now and my crazy path through 3 different majors. So now I can answer any questions that you guys have. And the next slide is my contact information if you want to email me later on if you think of something. Not right now, but in a couple hours or a couple days.
Just want to give you guys a chance to see that. Shannon, that was fantastic. Thank you for your presentation there. One thing I try to cover with students is so much is, in the work that I do, I'm aware of the fact that so many jobs change and the world of jobs changes radically, especially because of technology. So I find myself wanting to ask, what's the future of industrial engineering as far as you see it?
Great question. In my field in particular, what we're really focused on is designing automation, whether it be for vehicles, whether it's in healthcare settings, whether it's in manufacturing settings. How you design automation to still be able to work with humans, right? So example, in a manufacturing plant, in particular, I was thinking about a project where you have an automated forklift, right? So usually you have people driving forklifts and they pick up pallets and they move equipment from point A to point B. But if you have an automated forklift who can do that, move things from point A to point B, what then does the human do? Especially a human who's still working in that same space. So how do you delineate space for where the humans walk and where the automated forklifts turn and maneuver? How do you communicate the actions of this automated forklift to a human operator? So that's one aspect of where industrial engineers are focused on. How do you design automation to still work with humans, whether the human is operating the automation or the human is just working near the automation? Another thing that's getting bigger and bigger is the importance of how you optimize the healthcare setting. And this is super important now when we have hospitals that are overloaded with people who are potentially sick with the coronavirus or people who are sick with something else, but you need to keep them physically separate from those who might have the coronavirus. So how do you optimize that situation? How do you make it as efficient as possible? Because you don't want people to be exposed to that risk. How do you figure out, and I know people who are doing this, it's very difficult. How do you choose which person gets which ventilator? These are all things that industrial engineers are often dealing with. And as we go forward into the future, I'm sure problems in the healthcare setting in particular will keep cropping up. And the last thing that I want to mention, which industrial engineers are also focused on a lot right now, is supply chain problems. So the supply chain is a huge system, and the supply chain considers the product from its very beginning. So if you're talking about milk on a farm, that's where it starts, literally with a cow. And at the end of that supply chain is getting milk into your refrigerator at home. So going from the cow to your home is a bunch of different steps. How do you optimize that process to get the milk from the cow to your refrigerator as fast as possible? That's becoming super important now because we have two food distribution systems, one that's for restaurants and one that's for consumers. Restaurants are using less food, so their supply chain isn't as used right now, but people are going to the grocery store a lot more. So how do you ramp down one supply chain and ramp up another one? At the very beginning of this crisis, I'm sure you guys saw, but literally farmers were throwing away milk. They were throwing away really good food because there was no way to get it to the consumer. So industrial engineers work on how do you optimize that process to make sure we can get the food from the farm, in most cases, directly to the consumer to make sure that it doesn't spoil or take too long in the process. So in the future, I see, those are just 3 examples of how industrial engineers, how their jobs will change, but also how important they are.
You know, I have a brother who's an engineer, and he's always tinkering on ideas that directly impact the world around us. That's what I find so fascinating about it, is that it's a truly real world application of skills to change environments, to change how people do things, to improve safety. And I remember, I'll never forget hearing that the landing of the moon was an engineering feat.
Mm-hmm.
People would perhaps miscategorize it as some other type of scientific feat. It was an engineering feat. It was about taking a machine and putting it from one environment into another at a great distance. And I thought that was an interesting way to phrase it. I want to open up the floor here to any of the other students who are attending to find out what kind of questions do you have about engineering or about career path or earnings or, anything like that related to industrial engineering.
Ooh, what would you say your
Great
job stress
question.
level is? Well, that's a very interesting question to ask me at this particular moment in time, because I actually just had a baby in December, so I'm on maternity leave. So my job stress level right now is pretty low.
Congratulations.
But when I go back to teaching full time in the fall, my stress level will be higher than normal, simply because it's highly likely that I'll be teaching online, which is something that I've never done before. Now, generally speaking, when we're not in these crazy times and when I didn't just have a baby, my job stress level, I would say, is higher than average, but manageable, in the sense that I get to work on something that's my passion. If you work in a field that you don't really like and that you don't really want to do that work, your stress level can be very high just because you're unhappy. But I really love what I do. I get to work with really bright, creative students. I get to work in the field of transportation, which I didn't mention before, but I kind of got into this field because I love driving. And when I was young, I loved speeding. I don't do that anymore. But I get to work on transportation, which I really love, really bright students. And as a professor, one of the coolest things is the fact that you get to control your schedule. I have to teach at a certain time. I can't just teach at any hour of the day. But outside of teaching, I can do the research when it suits me. I can take vacations. I don't take them very often when I want to. I can come into the office when I want to. I can do it with students when I want to. Having that flexibility is really, really great.
Wow.
Hi. So I had a question on how in general you come up with research questions.
Ooh, so it's a great question. And I kind of hinted at this before. I get them from the students. I kind of cheat. When I was young, I had really great ideas. And as I was saying before, as you get older, you kind of get stale. Life changes and you're not able to keep up with all the cool things that are happening. But younger students in particular they know a lot of things that I'm just not in touch with as I get older. So I have to admit that some of my ideas, a large majority of them, come from students. My other ideas come from things that I encounter in everyday life that I wish were different. So I may be doing some simple tasks like cooking, paying bills, walking my baby in a stroller, and I see something and I say, this is overly complicated. It shouldn't be this way. That's another really great way to come up with research questions. Something you see every day that you just get fed up with, and you know that it can be engineered in a better way.
Yeah, I'll give an example. I was just selecting my benefits from my agency last night. And you guys, benefits are all the other stuff like, do I want a vision plan? Do I want a dental plan? All that kind of stuff. But you'd think it would just be easy, check off a bunch of boxes or whatever. It was like going through an obstacle course or something. I had to do this and then get online here and go. It took me hours, and it was really frustrating to do it. And I did say to my wife, I was like, why isn't this easier? Why isn't this better designed? But it would be an engineer like you're talking about, and who would take care of that.
Exactly.
Yeah. I mean, one question I always try to bring up with professionals is, what's the sort of pay scale that somebody can expect at the level that you work at?
Yes, great question. So when I first got my bachelor's degree, I was looking at jobs, and granted, this was in 2009. It's very different now because that was 11 years ago. But starting salaries for mechanical engineers at that time were like between 60 and 70,000, I think. Once I got my master's degree, I didn't look for jobs, so I don't know what their pay range is. But when I graduated with my PhD, I looked at jobs in 3 different places. I interviewed actually at Apple, and I got an offer, and I can tell you how much that was. I worked at MIT, which is a federal lab, and eventually I went to academia. So actually across all 3 of those spaces, the pay was actually very similar. When you get your PhD in engineering, if you take a professional full-time role, not a job that is like a gap in between your full-time job, the minimum you can expect is probably like 110,000. And depending on your field, it can go way up from there, way up. Especially when you work at, for example, a company like Apple that often gives you bonuses and stock options. This is your base salary, but then when you get bonuses and stock options, the money that you take home every year can increase like up to 50%. So minimum 110 when I was looking for jobs 6 years ago. So of course that's gone up since then, and it can go way up from there.
Yeah. It tends to be a pretty well-paid field if you're especially if you're in industry. That's at least my understanding. Yeah.
Yes, definitely.
Yeah. That was a great question about stress, I thought, because that's a big part of every job, is to think like, what's the kind of stress I'm going to encounter. I remember having a conversation with somebody, for example, who made nature documentaries down at WGBH in Boston. And I asked him, I said, so like, how stressful is this? And I was surprised because she said, it's actually pretty stressful because I'm under deadline. I'm having to work with a creative team that maybe they're running into problems. Maybe they haven't, caught a film segment of a lion doing what they wanted to see it do. So they got to stay out there in the field or something, So that's a great question about stress. Anything else that you guys want to know?
Ooh, what made you choose vehicles?
Yeah.
So I was kind of different as a teenager in that most people learn how to drive when they're 16. I didn't learn how to drive until I was 18. So I was essentially waiting, just sitting on my hands, like, I really want to drive, I really want to drive, I really want to drive. And then I did. And I was so excited. And that excitement just carried me through my career. I found cars always to be really interesting, really fun. I love to work on the design of something that people see and use almost every day. It's not a product that you only use once a week or once a month. And it's fun to work on something that people often use as an expression of themselves. So when you guys get old enough to buy a car, you'll see that there are tons of options out there. And it's a big decision because it's expensive, but people choose the one that they think really represents them and who they are. And like I was saying before, I find driving to be just a really fun activity. When I was younger, I liked going on road trips. Now that I'm older, I can't sit that long. My joints and things start to ache. But I liked road trips when I was younger. I liked seeing the country through the view of the car windows versus in an airplane where all you see is clouds. Driving to me is just a really fun thing.
Cool. Anybody else have questions? Well, Shannon, I so appreciate your time today. I know it was a cold call out of nowhere. And you should know these are all recorded, and I've got at least 40 students who are signed up in general who are participating in all these stuff. They're checking out these videos. And you'll see I also emailed you about this larger program that we're part of, the STEM at Work paid internship program. So I'll circle back with you separately about that. But I love the idea of your lab. I love what you're doing because it's so concrete and hands-on for people and I have tons of kids who are interested in engineering. They just don't know what kind. They have some loose ideas or basic ideas about engineering, but they really do want to go further and get into it. So I'll certainly share this video with them, and I hope we're able to be in touch more as my other program unfolds. I'll keep you posted.
Sounds good. Well,
right.
I had a great time. Like I was saying before, you guys are so thoughtful and so creative. I wish more students were like you.
All right. Thanks so much.
Thank you. Bye-bye.
Yeah. Bye-bye.